I'm glad you came to our practice final exam review. This is the best way to study for the final exam. The practice final will show you what areas you need to go back and review on. Remember, the virtual tutors are there to help you, I'm here to help you, and our care coach is there to help you. So let's get started. At the beginning of the practice final, you'll see that I've included a list of formulas. I've decided this semester to include that on the practice final and on the final exam. It will appear in the same location on question number 1 if you need to go back and reference it. So these will be on the final exam in question number 1. For this final, you need to make sure that you record your work. On the midterm, several people just turned in basically scratch paper. No, what I want you to do is I want you to number it. So number your problems that you need to show work on. That way I can find your work and look for partial credit. I do look at everyone's paper, and I look for work, and I look for any kind of partial credit that I can go back and override my math lab on. So please give me as much as I can and make it easy for me to find your work. You may not use any notes. You may use any calculator or the Desmos webpage, but you may not leave the Desmos webpage or they will kick you out of the testing center. Okay, let's start with number 1. There will be 2 factoring problems on the test, and they're going to start the final exam. We'll open up with those. It is so important to leave this class with this skill. And I taught bottoms up method, and that's what I'm going to review on here, but there are other methods, and I do not care which one you use. You may use whichever you like. The first thing you always want to do, though, is check for a greatest common factor. And if you don't see the greatest common factor, I told you an easy way to do this would be to make a factor tree. You choose 2 factors that multiply to be the number. And then you keep choosing 2 factors until you're left with a row of prime numbers. So the only factors are 2 times 1 that will make a 2, a product. And so 2 is prime, 3 is prime, and 7 is prime. If you multiply 2 times 3 times 7, you get 42. That is our prime factorization. And I also expand out the variable. I could do 58 the same way. Well, 58 isn't on my times table, but I know it ends in a 0, 2, 4, 6, or 8. So I can divide it by 2. And 29 is prime. And then 20, I'm going to say it's 4 times 5. It wouldn't matter. You could do 2 times 10. At the end, when you go to the bottom row, you'll always end up with the same thing. And I gave you a tip when I was teaching this earlier in the semester that I always add a 1 in front, because the greatest common factor is anything besides 1, but it will help you remember that if you take all the other factors that you need to hold the place open with a 1. But you can see in this case, they all have a 2. So the greatest common factor is a 2, and I put that in the front. And that will leave me 21x squared, that's 3 times 7, x times x, plus, match the sign, 29x, match the sign, and then 2 times 5 is 10. Now I count the number of terms, 1, 2, 3. There are 3 terms, and when I have 3 terms, I want to use bottoms up. You don't have to use this method. You may use whatever method you like. One other tip too, I would go ahead and type 2 in the answer slot, because that is factor. That is our greatest common factor, and so it's ready. Oftentimes it's forgotten. Don't forget that one. But you need to check to make sure that you can't go any farther of what's inside the expression here, inside the parentheses. So we have 3 terms. I'm going to say A is 21, B is 29, and C is negative 10. Remember, you need to take the signs to their left. Then I multiply A times C. 21 times negative 10 is negative 210. And I want to write all the factor pairs for negative 210. And don't let this intimidate you. It only takes a minute. I just went ahead and wrote this side here. I just go straight in order. I start with 1. I say 1 times 210. And then 2, well, it ends in an even number, so I just divide 2 times 105. And if you don't recognize these quickly, just use your calculator. It has to be a whole number, though. It cannot be a decimal. And then I recognize that it's a negative 210, so it's either going to be the first factor that's negative or the second factor that's negative. That's how I wrote these, and you wouldn't have to necessarily write those, but I just wanted to for the review. But what you do is you stop when you get a factor pair that adds to be 29. So usually I'm kind of watching for it, so I would have probably stopped right here and said, wait, 35 minus 6 is 29? And I would have stopped there. So I have my factor pair as negative 6 and 35. And the bottoms up method says you write an x always for the first term, whatever the letter is, the variable you're in your trinomial, and then you write that factor pair for the second terms in each parentheses. You're not done though. You have to divide by a. Okay, so this is your factor pair. And now you're going to divide by a. And a was 21. Remember, we're doing inside the parentheses here. And then you want to simplify the fraction. So this would be 3 times 2 and 3 times 7. So 2 7s. And this would be 7 times 5 and 7 times 3. So 5 thirds. And then bottoms up says that you take that denominator and you move it in front as a coefficient of the first factor. So this becomes 7x minus 2 and 3x plus 5. And I would check that. I would say 7x times 3x, that's 21x squared. And then 7 times 5 is 35, minus 2 times 3 is 6. So 35 minus 6, that is 29. And then I would check my last term times my last term. So negative 2 times 5 is negative 10, and that is correct. So this is completely factored. Next, I'm going to factor my next problem. And I can see, first I checked with my greatest common factor again, so let's just check that. So 75, well that's 3 and 25, and 5 and 5. 147 is one that I don't necessarily recognize off the top of my head, so let's just try that one. So 147, I usually try divide by 2. No, I can see that's not because it doesn't end in 2, 4, 6, 8, or 0. And then I'd probably try 147 divided by 3, and that one does work. And you can, the rule on that is you can add up the digits, and if they're divisible by 3, it's divisible by 3. But you guys have a calculator, just use your calculator and try it. Probably quicker on a final exam. And then to make a 49 is 7 and 7. Oh, so we do have a greatest common factor because if I wrote these above each one, 1 times 3 times 5 times 5 times x, and then 1 times 3 times 7, you can see that they both have a 3. So 3 times 25, x squared, 5 times x, match the sign, and then 7 times 7 is 49. Once again, I put this on my answer space, type it in so you don't forget it. Now though I want to say, can I go farther and factor inside the parentheses? Well, I have 2 terms. And with 2 terms, you're either going to have a difference of squares, a difference of cubes, or a sum of cubes. Remember, the sum of squares is prime, which means you can't factor it. Okay? So you want to have these 3 that you know. Okay, so for the final exam, I'm going to tell you though, it's not going to be a difference of cubes or sum of cubes. A little tip. Instead, watch for difference of squares. A difference of squares is a squared minus b squared is equal to a plus b times a minus b. Okay, so I can see it's definitely squares anyways though because this is a 2, the exponent. So I'm looking for, can I rewrite this as something squared minus something squared? Well, clearly 7 times 7 is 49. And then to get 25x squared will be 5x. So using my rule that I memorize, I make 2 sets of parentheses, and the a goes in the first term spot, and the b goes in the second term spot, and it's a plus and a minus, and that is completely factored. Number 4, solve the equation 4 raised to the x minus 7 is equal to 16 to the 4x. So the first thing I want to do when I'm solving these basic exponentials is to ask myself, can I rewrite them with the same base? Because that's the easiest method for solving two exponentials that are equal to each other. So in other words, the left is 4 to the x minus 7. And I know that 16 could be written as 4 squared. That's the same thing. 16 is 4 squared. Okay? So I just rewrote 16 as 4 squared so that I can have the same base. But I need to go ahead and simplify this. 4 squared raised to the 4x means I'm going to multiply the exponent times the exponent. So I need to make sure I multiply this. 4 raised to the 8x. And on the other side, I have 4 raised to the x minus 7. So I want to solve this now. And I can use the same base property. And I know that when they have the same base, all I need to do is equate the exponents. So since they have the same base, all I need to do is say x minus 7 is equal to 8x and solve. So let's see. So I'm going to say minus x. And then I'll divide both sides by 7. And I would want to check that. So I would say 4 to the negative 1 minus 7 is equal to 4. My original problem said 16 to the 4 times negative 1. And that would be 4 to the negative 8 is equal to 16 to the negative 4. And I could use my calculator and check that if I didn't see that. So 4 raised to the negative 8. You can see I get this number. 16 raised to the negative 4. You see I get the same number. And so on a test, I would just check it quickly myself to make sure I didn't make a mistake. And that one is done. Negative 1. And I will put on here x equals, so you'll just enter in the negative 1 in the box. Let's do the next one. Number 5. Solve the equation e raised to the negative 0.18t is equal to 0.56. Now, e is Euler's number. It is a number. It's not a variable. So you can rewrite this as a log, and this should make this a pretty straightforward, easy problem. Now, there are different ways to solve this. This is not the only way. So this is one way to solve it. One way to solve this is just to rewrite this as a log. So we know that the symbol here, well, let's see. We know that if we rewrite this as a log, that I know that I say my mantra is a log is another name for an exponent. So before you rewrite it, label your parts. The base is always the number that's sitting on the line, like if you drew a line here. Okay, this is my base. And the exponent is always the number that's raised, or variable name that's raised. This is my exponent. Okay, so let's put them where they belong. The base, we know log base is the subscript. So my base is going to be e. A log is another name that's equal for an exponent. Okay, so that means my exponent will go right here on this side. And then my argument will be on the other side of the equation. So I just filled it in. Now I know that log base e is natural log. That's another name for natural log. So now I just need to solve for t. So I'm going to divide both sides by negative 0.18. And I'm going to use my calculator. So I have my scientific calculator here. So I'm going to find the ln button. It's right here. And I'm going to type in 0.56. Notice you have to close the parentheses on this calculator. And then I'm going to divide by negative 0.18. There's a negative on the bottom row here, if you're looking for that. And then hit equal. And I get 3.2212. And it asks me to round to 3 decimal places. So let me just write this to make sure we're all good at rounding. This is what my calculator shows. But it says to round to 3 decimals. So 1, 2, 3. I look at the next decimal. And I say, wait, is that 5 or higher? It's not. So I'm going to leave it as it is. So it's going to be 3.221. The next question just said, what is Euler's number rounded to 2 decimals? So you can memorize this, or you can use your calculator, and you can just type in the E. So you can see right above the ln of x, this right here, ln, above it, and the blue is e to the x. So if you ever forget what e is, Euler's number, hit second, and then the ln button, and you can see it puts e raised to, let's just raise it to the 1 power, because if anything raised to the 1 power is itself. So if you forget, it's 2.718281828. So we're going to round that to 2 decimals per the directions. So 2.72. And on Desmos, also you can do E for Euler, and it will give you the same thing. It will give you the value. Okay, number 7. If you rewrite a log, if you rewrite the exponential equation, 5 to the x equals 100 as a log, what does it become? So we're just going to rewrite this as a log. So a log is another name for an exponent. Okay, so I go ahead and myself make my little template here. We know this is always the base. And we said that a log is another name, that's equal, for an exponent. So that side's the exponent. So if we need to label this, that's my base. This is my exponent. And then my argument is the other side of the equation. So it would be log base 5 100 is equal to x. So let's pick this one. Now, I want to point out quickly, though, that log base e of x could be written as the natural log of x. Log base e is the same thing as natural log. And also that if you have log of x, this is the same thing as saying log base 10 of x. So we don't typically write the 10, that's a common log. But if you got log base 10 of x, realize that that is log of x. Number 8, solve the equation. 10 to the x is equal to 5 to the x plus 3. Now I told you the first thing I always do is say, can I get them to the same base? But I cannot, because I know that 10, right, is not it has no base. I can't write it as an exponential. 10 is just 2 times 5, so it's not anything multiplied times itself. So 10 cannot be written as 5 raised to anything. Because think about it, 5 raised to the 1 power is 5, 5 raised to the 2 power is 25. So clearly I cannot write this as a base of 5. So I'm stuck. So what do I do? And you could do this, you could also use the same idea for the earlier problem we did if you didn't want to write it as bases. So what you can do is you can take the log of both sides. So let me get a different colored pen. So if I were to take the log or the natural log, it wouldn't matter, of both sides, right? Then all I need to do is use my power property. And my power property, remember, says that when you have an exponent on the argument, because this is like this, you can think of it this way. If you have an exponent argument, you can rewrite this as x log of 10 and x plus 3 log of 5. That's what the power rule tells us, that when we have an argument, we can put it as a coefficient in front of the log. And we do this to get the x out of the exponent. So let me go ahead and just distribute this right side. So I'm going to make this be log 5 times x plus 3 log of 5. I just distributed this to both terms. And this side we have x log of 10. Okay. I'm going to move the x terms to one side so I can factor out the x. So I'm going to subtract log 5 times x from both sides. And I'll get x log of 10 minus x log of 5 is equal to 3 log of 5. My goal is to get the variable that I want to solve for alone. So I want to get it on both sides, on one side of the equation, and then factor it out. So I see I have an x in both terms, so I'm going to factor it out. And now I'm just going to divide by log of 10 minus log of 5 over log of 10 minus log of 5. Okay. And we can go ahead and put that in our calculator. Oftentimes this is where the mistakes happen, so that's why you want to show your work and label the number. So this is what I'm trying to enter, 3 log 5 over log 10 minus log 5. So I'm going to use my calculator and show you where the errors happen. So I'm going to say 3 and then log 5. Notice I have to close the parentheses, and I'm going to divide by. Now, when I'm dividing, I want to make sure I divide with the parentheses here so it knows I'm going to take this entire difference. So I put a parentheses, log of 10 minus, and then do it again, log of 5. Notice I have to do another parentheses to close that. Okay, I'm going to hit enter. And I get 6.96578 and so on. So it says to round to 3 decimals. So this is what my calculator shows. So to round to 3 decimals, I look at the number to the right of the third decimal, and it's greater than 5, so I'm going to change this to be a 6. So 6.966 is my answer. Now, I'm going to recommend on the final exam that you use Desmos to enter this when you're simplifying this. Because Desmos, you can see what it looks like. You can see that you didn't make a mistake and how you entered it. Okay? But make sure you show your work, so if you do make a mistake, I can give you partial credit. Okay, let's look at the next one. Solve log base x of 256 is equal to 4/3. Okay, so there are many ways to do these problems. I'm going to show you my way. So I would just rewrite this as an exponential. So we know that this is the base. We call that log base x equals of 256. And I told you that a log is another name, that's equal sign, for an exponent. So now I can set it up. I know this is always my base, and this is always my exponent for an exponential. So I'll put my base of x, and then I'll raise it to the 4/3 power, and I'll put my argument here. So I have x to the 4/3 is equal to 256. And we learned how to do this earlier, that when I want to solve for a rational exponent, I can multiply times the reciprocal, so 4/3 times 3/4. Because 4/3 times 3/4 would give me 1. And then 256 raised to the 3/4 power, so I'm going to use my calculator. 256 raised to the parentheses, 3/4. Remember, whenever you're talking about a rational expression, put it in parentheses, and I get 64. And we could check that. I should check all of them, especially on the final. I'd probably check all of them. So let's go ahead and check that. Let's put it back in here because we know that sometimes our answer will be an extraneous solution. So let's just check this. So in Desmos, you can see that you could easily check this on using your function key because it allows you to enter in a base other than 10. But on my scientific notation, my scientific calculator, it does not. So let me remind you of the change of base formula. So here's the change of base formula. So the way I always remember it is that the base goes on the bottom. Base on bottom. And you'll notice I have a C here for the base that I'm changing to. But in reality, you're probably going to always use just 10. So you're just going to not worry about that. So I'm going to cross that out to just make it easier. So this is what I remember. I just remember that when I have a base, that's not what I want. I take the base and I put in the denominator, and then I paste the argument I put in the numerator. And then I just use log, or I use natural log. Either one would work. And let's do that on the calculator. So I would say log of 256 divided by log of 64. And that's 1.33333. That is what 4/3 is. So that does check. But I checked it just to make sure. And on the final exam, if you're worried about time, you have 2.5 hours. But basically, so if you have time, you can come back and go back through and check. If that makes you nervous, just do them first without checking, and then go back through and check all of them. Okay, the next one, number 10, solve the equation. The natural log of x plus 12 plus the natural log of x minus 5 equals 2 times the natural log of x. Now, all of these have the same base. Just like we have the same base property for exponentials equations, we're going to use that same base property for when we have the same base. So all of these have the same base, all three of them. So I could rewrite this as the natural log of x plus 12 plus the natural log of x minus 5 is equal to the natural log of x squared. I took this 2 here and I moved it as an exponent because now I have the same log and base. Okay, so I know I can start doing some magic here. So first of all, let me combine these two terms. So natural log of x plus 12 plus natural log of x minus 5. Using the product property, we know that when it says plus between two logs or natural logs, that we can just multiply the arguments and make it into one natural log or log. Okay, so let's go ahead and multiply that. So that's going to be x squared plus 12x minus 5x minus 6e. So that's going to be x squared plus 7x minus 6e. So now, when I have the same base with a log on both sides of the equation, I can just equate the arguments. Just like earlier we said we could equate the exponents, now we're going to equate the arguments. So I'm going to say x squared plus 7x minus 6e is equal to x squared. And this works because they have the same base and log on both sides. So now I can just solve this. Well, I'm going to subtract x squared from both sides. Well, that's nice. That goes away. And now I have a simple linear equation. I'm going to add 60 to both sides. And I'm going to divide by 7. And I get x is equal to 67. Okay? And it wants us to round that to 3 decimals. So let's go ahead and do that on our calculator. On our calculator, 60 divided by 7 is 8.5714285571. And it said to round to 3 decimals, 1, 2, 3. I look at the next decimal, which is 4. It's less than 5, so I'm not going to do anything. So 8.571. Okay, so now we have the first 10 problems done. Woohoo, we can do this. Number 11. Suppose that the population of Westovia grows continuously at 2.1% per year. Westovia is a country I made up. It sounds to me like it needs to be in like the Princess Diaries or one of those princess shows you come on like the Hallmark Channel. The population is 3.4 million in 2020. How many years will it take for the population to double? Round to the nearest year. Now, you can do this the long way or the easy way. I'm going to show you the easy way. The doubling formula is always going to be ln of 2 over k. So you don't need to do anything besides that. So we're just going to find what k is. And k is that growth rate as a decimal. So It told us that it's continuous growth, and it's going to be 2.1% per year. So 2.1%, the word percent means divide by 100. Like miles per hours, it's divide by hours. So percent, like cent for century or cents in a dollar, is 100. So divide by 100. So 2.1 divided by 100, if you use your calculator, is 0.021. And another way is you can move the decimal to the left 2 places if that works for you. So I'm going to say t is equal to ln of 2 divided by 0.021. Now the ln button, you know, on our calculator is right here. Okay, so make sure if you're using a different calculator, you know where it is. On the on Desmos, let me look and see where it is. I believe it's the function key, but I believe you can also just type in ln. Let me just check for you. Yeah, if you put in ln and then parentheses, it does understand, or just write ln of 2 in Desmos, and it would be able to do it. So you can find that there. You could also find it on the bottom left key under where it's a little keypad, and scroll down. It's listed in our calculus, so that if you don't remember that, you can look down the little keypad on the bottom left of Desmos. Okay, and when you type that in, so ln of 2, close the parentheses, and then divided by 0.021. So I'm going to get 33.0070, and it tells me to round to the nearest year, so that's going to be 33 years. Okay? And you don't need to put units because I'm asking how many years, so you would just enter that number. Sebastian deposits $14,000 in an account that pays 6.3 compounded continuously. We already in the last section talked about periodic compounding, so the final exam will not be that. Instead, it's going to be about continuous compounding. So you have to memorize the formula is going to be A is equal to PE to the RT. So you need to make sure you memorize that. I don't think, let me look, I don't think I included it on the front page. I did. Actually, I did put that on the front page. So here in the front page on the first question, I gave you compounded periodically and compounded continuously. But we're going to have on the test here, so watch for the words. If it says compounded continuously, you're going to use this one. Okay? So if you need that one there. Oh, and here, look at this. Here's the doubling time formula too. So if you need that one's there too. So far, we know both of those. Oh, and I'm realizing too, so here is the product property for logs. And here I gave you the difference property. And here is the power property. Okay? And I forgot I gave you these. This is the change of base formula that I just discussed. Typically, I don't give a formula sheet, but I thought since we're doing the testing center, let's just do that. I saw a lot of other teachers who were doing that at the midterm. So this will be on your final. And like I said, I just realized that's a lot of key information that you will have right there. So maybe print that out and make sure you know it and you're comfortable where it's located. Okay. So here we go. So P, that's going to be my principal. That's going to be 14,000. E is Euler's number. R is the interest rate. Now 6.3, we know we have to divide by 100, so it's going to be 0.063. And then T is 7 with the number of years. So just to remind everyone, P is principal, the amount of money you're putting in. R is the interest rate as a decimal. That's really important. And T is the number of years. Okay. So let's put that in our calculator. So 14,000 raised to the, notice I'm going to put parentheses, 0.063 times 7, and then I'm going to close my parentheses. This is where people will make the biggest mistake and they'll get it wrong. So show your work. They will forget that when you're putting the calculator, put parentheses around that product so that the calculator knows that it's E raised to the whole product, not just E raised to the 0.063, and then that times 7. So if you don't put parentheses there, the calculator will see this. And that's not what you want. You want this to be up in the exponent. So don't do that. Make sure you put parentheses around that exponent. If you use Desmos, you won't have that problem. You'll see that. You visually can see it. Okay, I just can't transfer my screen, or I would do that for you. So when I'm recording this. Okay, so when I do that, let me do that again. So 14,000 raised to the parentheses, 0.063 times 7, close parentheses, and I get that does not seem correct. Let me do that again. I skipped the E, sorry. Let me try that again. 14,000, okay? And then times E, so I want to go second, and then over here where the ln is button, that's E. So E raised to the 0.063 times 7. And I get 21,759.65. I'm rounding to the nearest cent. So let me make sure that since I entered that in wrong the first time, remind you. So you're going to enter in the principal. And then this is important. That's what I was like, that doesn't make sense. I forgot to enter the E. Okay? To find the E on the scientific calculator, you're going to say second. And then above ln, it has e to the x. And it gives me E raised to the 0.063. And then I will multiply times 7. And I'll close the parentheses. And if you use that button, you can see that if you leave it inside there and close the parentheses, it knows that 0.063 times 7 is the exponent, and you'll get your answer. Okay, so let's try the next one. For the systems of equation, and it gives you two, one solution is, okay? So we're given a system of equations, x squared plus y minus 1 squared, and equal to 100. And 96x is equal to 1. And it wants us to solve this system. And when you're solving a system, it means that your solution has to be a solution for both equations. So it's giving me one of the solutions. It says, wait, is this a solution? That's what we're trying to find out. Is 6, 9 a solution? But that's not for one of the equations. It has to be for both of the equations. So in other words, if I put 6, 9 in here, 6 for x and 9 for y, will both be true. So let's try this. So I'm going to replace x with 6 and y with 9. So this becomes 9 squared plus, 6. 6 is x. 6 squared plus 9 minus 1 squared is equal to 100. That's my first one to check. But I also need to check 9 6 times x, which is 6, is equal to y, which is 9. I can quickly see that this is true. 9 equals 9. That one is true. Okay? Now let's check this one here. So this is 36 plus, and this will be 9 minus 1 is 8. 8 squared is 64. 36 plus 64, well, that is 100, and that one is true too. So 6, 9 is a solution because it made both equations true. Number 14. The solution for a system of nonlinear equations, inequalities, is shown. Which order pairs are solutions? So I didn't actually give you the inequalities. I just gave you, if you were to graph each inequality separately, this is what it would look like. This is the solution for my first inequality. And then the circle, the outside of the circle is the solution for the second inequality. And I want to see if you understand how to use that. So what are the solutions for the system? Remember, for the first inequality, everything on this side is a solution. And for the second inequality, everything outside the circle is a solution, but not including the edge of the circle. That's why it's dashed. So the solution for a system means that it has to be in both solution sets. So let's look and see. We have 5, negative 2. So 5, negative 2. That's right here. That is clearly not a solution because you can see it's not in the shaded area for both of the inequalities. So that's no. How about 8, 12? 8 and then 12. Okay, so 8 and then 12 will be right here. That's a tricky one. That one there falls on the line. So that means it is a solution for this inequality, And it also falls in the outside of the circle solution. So yes, that is a solution for the system. How about negative 5, 5? So negative 5, 5. So negative 5, 5, it falls in the solution shaded area of this inequality, but it does not fall in the solution of the circle. You can see it's not in the shaded part for both the circle and for this other inequality. So we know that this is not a solution. It has to be in both of the shaded areas. How about negative 11, 5? So negative 11 and 5 would be up here. Well, this one is in the shaded solution area for the linear inequality and for the circle. It's in both. So yes, that one is a solution for the system. Negative 9, 8. So negative 9 and 8 would be right here. So negative 9 and then 5, 6, 7, 8 would be right there. Negative 9, 8. That looks to me like it would also be a solution. It is also in the shaded area, so let's try that. Let me make sure I didn't misgraph that. Yep, that one's also true. Negative 8, 7. Negative 8, and then 7. Now that one falls right here. That's a tricky one. Look closely at that one. That one certainly is in the solution area for the linear inequality, but for the circle, it falls on the dashed line. And the dashed line means it doesn't, the circle inequality does not include the edge, the line of this border of the circle. So that is not a solution. To be a solution with the system, it has to be a solution for both inequalities. Okay. Let's try the next one. Okay, this one says, be able to identify all 9 basic functions we have learned this semester. Name a function, graph, and algebraic equation. Now, I'm not going to go through this one because I actually put this in the answer key, which follows this, the practice final exam, and I actually put the graphs and the names and the algebraic representation. But what I'm saying here is I want you to be able to recognize that if I were to give you a graph that looks like this, right? That you would say to me, this is the absolute value function, and the algebraic representation is y is equal to the absolute value of x. There are 9 of them we've learned this semester, and I want to make sure that you recognize them. It'll be a matching problem or some kind of true false or something like that where I'll give it to you and you'll have to match them or tell me if it's true or not. But you need to make sure you know all 9 of them so that you can recognize them quickly and give the name, the algebraic representation, and know what the graph looks like. Now the difference quotient, and I give this to you on page 1 here, so it is on your equation here. Oh, and I'm realizing this I'll fix this, but this really should be over here with odd function. It just ran off. But the difference quotient right here is f times x plus h minus f of x all over h. Okay? So I got that from my formula page there. So let's go ahead and try this. So people get confused. This should not be hard. I really want you to leave knowing this because this is really important for calculus and pre-calculus. When you're talking about the difference quotient, if I asked you what is, let's see, what is f at 1? Well, you tell me, oh, well, that's easy. I would just replace the x with 1, right? And if I said, what about f at 3? We'd say, well, that's easy. I'm just going to replace the x with 3 and simplify that. And if I said, what is f of t? Well, you know that's just going to be replace the x with t. So don't let yourself get confused when I say, what is f of x plus h? All I'm doing is saying, wherever there's an x, you're going to replace the x with x plus h. So I'm going to replace the x, wherever I see it, with the value of x plus h. Okay, everyone see? So it's just like we did when we evaluate. In place of the x, I'm going to replace x plus h. So now I know what f of x plus h is. That's the first term here. That's what my first f of x plus h. Okay? So I could rewrite this now as 2 times x plus h squared plus 7 times x plus h. That is f of x plus h. That's what we just did right there. Okay? And then f of x, well, that's just the given problem. 2x squared plus 7x. Okay, so that was just given. Everyone sees, so don't make it harder than it is. And then h, well, that's just h. So this is the only tricky part of f of x plus h, but just tell yourself, it's just exactly the same way as if you evaluated it if it were a number, but in place of the number instead, you're evaluating it x plus h, so you're going to replace x with x plus h. So now we're just going to do a little bit of simplifying. Let's clean this up. Okay, so I want to expand x plus h squared. One of the most common mistakes I see students make is they'll tell me that's x squared plus h squared. Bah! It's not. So don't do that. Instead, write it out twice. Isn't that what x plus h squared means? And then you won't screw it up. And I'm going to go ahead and distribute this negative to both of the terms that follow so that I have that done. I'm just cleaning this up, so I'm just going to multiply x plus h times x plus h is x squared plus xh plus xh. So it's going to be 2xh plus h squared. Okay, so it is not x squared plus h squared. You can see people forget that there's a 2xh, but if you write it out twice, you won't have that error. And then I'm just going to go ahead and distribute here, so as long as we're here. And then one last step, I'm going to distribute that 2 to each of these terms. Oh, that'll be a 4. And actually, I love doing difference quotients, and a lot of students, once you get the hang of it, you're going to like it because it's kind of fun. There's a lot of canceling, and people like that. Okay, so, oh wait, 2x squared and minus 2x squared, and 7x and minus 7x. Okay, so you're left with 4xh plus 2h squared plus 7h, all divided by h. And if things do not cancel like that, then you made a mistake somewhere. There should be a lot of canceling going on. But my last step is always just to factor out the h out of the numerator. And then I can simplify h divided by h is equal to 1. And I get 4x plus 2h plus 7. And that is my difference quotient. So please don't skip this problem. This one is really important for your next classes. And I really like you to spend a little time reviewing this. It's not hard. It's just following the math. Make sure you show your work. And if you get to this point alone, that's going to give you partial credit. You can just show me that you understood how to get that f of x plus h and you know how to put it in. So go ahead and show me your work. Make sure you label it clearly so I know how to find it. Number 17. Oh, let's stop now because this is the midpoint of the final as far as for the practice final since there are 32 problems. So I'm going to make this into 2 videos. So let me stop.